Okay, now let's try sharing the screen. Great, can you guys see my screen?
Yes.
Yes, you can. Cool. So as you see, I'm in Visual Studio. On the right here, how about that? I have today's lecture, which should be just about exactly what you expect it to be. I just made a small update, which you'll see, which has to do with something I saw during that little class time we just had. Trying to find a good place for this. Cool. And one more thing I wanted to do before we started going, I just downloaded this extension that is not necessary, but I have used it in the past. And it kind of, it makes, at least the free version makes doing what I would call playground type stuff with JavaScript nicer, where it's called Quokka, and I can say run on save for current file. This feature is only available in the Pro edition. Okay, never mind, we're not going to use it, it looks like. I'm surprised that used to be a free feature. Can I do anything in it? It's not really important. Okay, so as you see, the whole point, I mean, maybe we will use it here, but the whole point of Quokka is just that when I start when I type like, hello, and I save it, it's really supposed to be showing me something. I guess it's not free like it once was. Okay, never mind. We're not going to use Quokka. Right, so anyways, we're going to get into today's lecture, and this thing on the side here will just be us seeing how things work, because
sorry to interrupt. Daniel said you could use it.
What was that?
So in the chat, Daniel said you could use it. You just have to run it on the current file, not the save file.
Okay, so you're saying within here, if I said run it on the current file, not the save file, Quokka, like that? What do you say?
Daniel, do you want to elaborate, or does he have a mic?
Yeah, so I use it all the time. You have to, there's an option that says start on current file. Yeah, right there.
Great. Yeah. So as you see, I'm happy other people use it, but the basic idea of Quokka is just in what looks like a comment to the side, you'll see the output of something, and you'll see this little green thing here, which will tell you if the thing was run. So for example, if I said if false console.log, you'll notice that this line gets grayed out and this little box is gray. So it's just kind of a little nice way of letting you know what's outputted and what's actually being run. And at the free version does everything you care about. I think the paid version is mostly for seeing like asynchronous stuff, which is even more useful, but harder to do in that environment. Cool. So we will probably do some of that. I'll keep this here, but yeah, the whole point is you don't have to look at the output necessarily. But yeah, so today we're going to discuss a couple of things. The goal of today's lecture is really just to talk about and get more familiar with JavaScript. Pretty soon we're going to be working, or we're going to be teaching mostly backend stuff, because in these boot camp type environments, it's very common you do backend first and then front end, which makes sense because backend is the part of a website you, as the website maker, own, and the front end is what you send to someone else, and you have less control over that environment, and that ends up making things a little trickier. But I say that just to say that we're not going to see JavaScript again for a little while, but still it's good to be relatively familiar with this stuff. And we're just going to try and take what you learned in pre-work and expand on it a little. And this is probably going to be a pretty interactive lecture in the sense that there's more features of JavaScript at this point that I could possibly teach you in this period of time. At the same time, you're not familiar with lots of them probably. And so really the more you guys can lead it in terms of saying like, hey, I saw this, don't really know what it is, or I've heard about this concept, can you talk about that? Probably the more useful this lecture will be. But either way, we have stuff set up. And the first two bits, Sorry, what was that? Oh, that was just a weird sound thing, or no? Okay. You guys can hear me, right?
Yep.
Great. Yes. The first two things we're going to talk about are basically history of the internet and JavaScript. Just like yesterday with the Unix stuff, it's not terribly important. You don't have to remember any of this stuff, but it does contextualize why things are. And I personally love the story of the history of JavaScript because it's not the story of, oh, these geniuses came up with a genius solution. It's much more a story of how you have no idea if this project you think is unimportant is going to be very important. So we'll learn a little bit about that. So internet history. So yeah, the goal here is to explain why JavaScript is the way it is. So the first concept to discuss is basically this idea of backwards compatibility. So JavaScript is a pretty old language at this point. It was created in the 90s. And you might notice that unlike Python, Python had Python 2. And then eventually they said, hey, we made certain choices that we don't like so much. We're going to fix some of those choices with a breaking change we call Python 3. And that's the new normal. And they supported Python 2 for a long time. But after, a decade or more, they said, we're not supporting it anymore. You can't do that with JavaScript because what if someone wants to visit the Space Jam website in 2023? They still can, and it still works. And if I were to look in here, this is just, normal, what do you call it? Normal HTML and stuff. I'm going to go to sources. I know somewhere here, what was that?
Could you increase the font?
Yeah, hopefully I can. Can you guys see this any better?
Perfect.
Yeah, well, I just know I followed at least one of these links and so there's a JavaScript file here and probably not going to look as nice when we put it in here. But yeah, this doesn't look terribly nice. You can't see it that well, but you want to notice that there's things like this var statement. You don't see that as much anymore. And it's not used very commonly anymore, but everything in here, even though it was written in 1996, it still needs to run as if it was written yesterday. And so that is a fundamental design decision that is built into JavaScript as a language, which is or JavaScript sort of as the JavaScript standard, which is they never remove things, they only add things. And that's why if one were to go to the MDN website, MDN, the M stands for Mozilla. JavaScript with. The M stands for Mozilla. Mozilla, as we're going to discuss in a minute, created this browser Netscape, which was the first browser to have JavaScript in it. They invented JavaScript and they still have a say in how the web works. But basically, they keep this great set of documentation about the language, but you'll find things in there where you guys probably never heard of or encountered that in JavaScript, there's a with keyword. And I didn't encounter it until years into using JavaScript. And it's because when you go to the documentation, it's going to say, hey, we realized pretty quickly this was a terrible idea. Never use this. There's not a good reason this exists, but it does exist. And we can't take it out of the language now because someone might have used it. So you can learn exactly how with works. And it does work. But they're telling you we don't like it. And also that there's this modern thing called strict mode in which you can just at the top of your JavaScript file write, I believe you write use strict. Someone can perhaps correct me on that. It's something like, I forget the exact syntax, but there's a way in JavaScript of saying, hey, I'm in strict mode, which means don't even, if I use any of those terrible features, just warn me and don't let it run. And when you use a professional product like React, even if you don't see it, it's in there because no one wants these things, but they exist. But yeah, first let's talk a little bit about how a website works, because that contextualizes to some degree why JavaScript made the choices it made. So yeah, this is the basic idea. We have a front end and a back end. We don't have to get into too much of the specifics of what a database is versus an application server versus a web server. Really, theoretically, these could all just be one thing. But the important point is that we have a computer over here in the backend area. And then we have a computer over here in the front end area. The computer in the backend area, that's owned by you, the programmer or the company, whoever creates the website. And then over here is the front end. They have a computer. They have, they could have a laptop on Windows or Mac, or they could be on a phone. And they want to see your content, or at least they want to talk to your company or whatever it is on some level. And then this dotted line here is representing the internet, where there's this fundamental line where you're going to be able to, the front end is going to be able to talk to the back end to the front end. But they have to do it over these wires, and they don't really know who the other person is in advance. So they have to make some assumptions about how to communicate. Otherwise, communication is going to be impossible. So yeah, the original solution, or this is you've heard of HTTP. HTTP is what we call a protocol. So what a protocol is basically everyone who's communicating needs to speak a common language. Otherwise, they're not going to be able to communicate. And HTTP was that original thing that said, here's how anything sent over the internet can say exactly who and what they are and what version of this or that they're using, so that the person at the other end who gets it can interpret that and say, oh, I know exactly what you're trying to say to me. And the first thing you would send over HTML in the early days, or sorry, that you would send over HTTP in the early days is HTML. And HTML is the thing that I'm in a job, or I'll make a new file just so that it looks right. We'll say HTML. So HTML is the thing that looks like, this hello world. And this could just be an entire website that's all it is, just a div that says hello world. And that's something that your front end could, put a URL in the browser, google.com. And this is an early version of google.com where they only have this website, and they just send that right back and you can see it. And then over time, someone said, hey, that is good, but it could be better. What if we added CSS? And at this point, I'm going to see if I can just get, right, it usually looks a little something more like this. So this is where you would have your div that says hello world. And then someone can say, well, I actually don't, I'm going to take some stuff out. Why not? So it looks a little simpler. So you didn't just have HTML, you had CSS, and CSS can be, just like JavaScript, can be embedded within HTML. So it's really all just one big HTML document. I'm almost forgetting even, oh, it's style. Style is what it's called. So someone could add something in here and say like, hey, actually all divs are going to have a color of red and a background color of purple, because we want it to be really terrible. And this was a basic website for a while. And what we're describing is basically a poster, right? As in, it's going to be a 2D box, basically, and it could have any number of things on it, and they can be like colored and styled, and you have fonts. But fundamentally, it's not very interactable. The only interaction you had originally was something like a link. So the link is the A tag, and I could write click me, and then I still have no idea why it's called href, but ref meaning like reference. I could say www.anotherwebsite.com. And then this would, I keep trying to save, and basically, so this HTML page would have minimal interactivity in that it would allow you to go to another page. But importantly, the nature of how this communication worked is that the front end would say, hey, I want to go to website.com. Back end would say, cool, here's your HTML page. HTML page would arrive on the front end. It would be read by a web browser, because that's what reads these things, and it would display the web page, and that it would be done at that point. And the only further move would be that if you clicked on a link, that link could essentially update your what was in the URL bar and just bring you to a new website. And that worked pretty well for a while. Some websites are very creatable like that. So like if you think about an early version of IMDb, for example, that's just information. So you go to the main page, it has a million links, you click on one of those, that more or less works. But eventually people wanted interactivity. People wanted, well, at first people just wanted things like, some background keeps, or some image can like zoom in and out or something. That's interactivity, or at least that's something you might need a programming language for. And then interactivity would be things like filling in forms, for example. Certainly when you get to a modern thing like Facebook, you're in a very heavily interactive world where you never, the website never seemingly reloads, but things are constantly updating on the page. And all of that is only possible by going from what we have here, HTML and CSS, which is what we would call a markup language, and that it can represent data, but it can't really manipulate data. And JavaScript was the missing piece that said, okay, now you can manipulate things as much as you want. And we've mostly seen JavaScript in the context of, manipulating variables and things like that. But importantly, JavaScript allows someone to say, hey, we have this HTML page, but actually now that we're within the HTML page, so, I might have this script element, that's where your JavaScript ends up going. When you create a website, within here, I might say something like, okay, well, actually, I want to say window.add element. Is that what it is? No, it's not window. What is it? It's can anyone here remind me quickly what would be the built-in value that allows me to talk to the HTML? Anyone gonna?
Is it document?
Document, exactly right. So document represents this actual HTML document, and I could say add node, okay, append child, and then append child, H1, something like that. And basically, once this website runs, it would, render the original website, and then it would hit this script, and it would append this child at the end. And obviously, you can make it so that when something is clicked, it adds something to the screen. And that's the essence of why JavaScript is useful. But before you could have that kind of, interactivity, you have to create this language. And as the story goes, Mozilla, whatever it was called back in the day, but it was called something else, they created this browser called Netscape. And Netscape was a pretty good browser that a lot of people liked. It was competing with like AOL. I don't even think Internet Explorer existed in the early days. And at some point they said, hey, we want to add this interactive layer. So they gave the job to one person, this man named Brendan Eich, and apparently he had 10 days to work on it by himself. And he came up with something he called Mocha. And I guess maybe it was supposed to be a Java pun because Java was a big language at the time, but the marketing people said, that's not obvious enough, call it JavaScript, because then we'll definitely grab the people who are interested in Java. And it ends up just confusing people because Java and JavaScript are not actually related. It's literally just the result of a silly marketing ploy to take advantage of the fact that Java was incredibly popular backend language at the time, and it still is pretty popular. So yeah, why does JavaScript matter? Part of the reason JavaScript matters, and it matters even more than Python in a sense to web development, is that even though Python's a very popular language, when you're on a backend, you own that computer, so you can do whatever you want with it. You can use any language that works on that computer. And, if it's a common operating system, it's going to be any language. You could write your own language if you wanted to. You can do whatever you want in that environment that is the backend. But the front end doesn't work that way. The front end has a browser, and someone has to create that program of a browser, but the browser only speaks certain languages. And because JavaScript was kind of the first one to do this, people invested heavily in it early on and made it so that running JavaScript was very fast in the browser. And we're at a point now where even if JavaScript is not a great language, and it's certainly better than it once was because of all the updates that happen every year, but JavaScript can't be replaced because companies like Microsoft and Google and Apple, they made sure their browsers run JavaScript very fast, and they put so much effort into that optimization that nobody really wants to invest further in creating another language. And importantly, even if you try, so Chrome, actually only Chrome supports a language called Dart that was invented at Google. But and it will do everything JavaScript can do in the browser environment. But importantly, no one else wanted to do it. So it only works in Chrome, which means it's not terribly compatible between browsers, which means nobody uses it. And which means it doesn't get that optimization love over years and years and years where it gets faster. But the big downside to this is that JavaScript has some very weird ideas. The guy who invented JavaScript kind of took inspiration from a number of things. On some level, Java, purely on the syntax and sort of how it looks. But some of the core ideas are things that literally go back, at this point, like 70 years. One of the first programming languages that existed was this language called Lisp, L-I-S-P. Lisp made a couple of choices, including this thing called dynamic scope. Lisp version 2 took it out because it was such a bad idea, but Brendan Eich decided, hey, that's a great idea. We're going to use that. And it ended up being a terrible decision that later versions of JavaScript had to sort of adapt and clean up. There's this thing called prototypical inheritance. Eventually, you will learn about inheritance a little more when we do object-oriented programming. Most inheritance is what we call class-based inheritance. Class-based inheritance also technically exists in JavaScript at this point. It's what the class keyword is. But at the heart of JavaScript is this idea called prototypical inheritance that I'm telling you, I've tried to learn how this actually works like 6 times, 8 times. It's a weird idea. And you see JavaScript just littered with these weird ideas that modern frameworks, modern this, modern that, is all about getting you to never have to touch. But for better or worse, it's there at a core level. So the people who make those frameworks often need to know the details of prototypical inheritance or how the this keyword works in JavaScript, which is kind of unlike any other language and frustrating. But yeah, long story short, I just wanted to mention this. There's this thing called ECMAScript you might have heard of. If you've heard of ES5 or ES6 or anything else, that E is for ECMA. ECMA is just some organization that exists in Europe called the European Computer Manufacturers Association. They're just a standards body, and they were some of the people that helped standardize JavaScript, because in the beginning, every browser was making its own version of JavaScript. And they all called it something different. Netscape called it JavaScript, but Microsoft called it LiveScript or something. And they were all not really terribly compatible with each other. And ECMAScript was this goal to say, okay, we're going to have one version of it, and everyone's going to call it ECMAScript. And that specification took people like the specification and follow it, but no one really calls it ECMAScript. It's just something to know that that's what ES6 is. And at this point, you might have heard ES5, ES6. At this point, it's being updated on such a regular basis, but they just call it ES 2020, ES 2022. And every time they make a new feature, they put it in this yearly update. But really, the big ones were ES5 and ES6, where it went from a not great language to a pretty good language to a great language. And this is why we have things like the var keyword, where I'll close this right now. If I'm in here, I can say var x equals 1, and that works perfectly fine. But I could also say let x equals 1, and I'm not sure why it's saying that. And yeah, these two things seem to do almost an identical thing. They're the same, length of characters basically for that reason. But they're not quite identical, and the reasons for it, we're going to get into very slightly here. But the important thing to know is just that things like let is sort of this solution after years and years to saying, hey, we found all these issues with var, now we have let, and there's no reason to use var anymore. It's just something you got to know about because you will see it in legacy systems. But we're getting further and further away from the time where it's commonly used. Yeah, so just a point on Node. JavaScript was originally created for the browser, and that's where it's generally run. So if I were to open my browser, I can go like this. And I think because of how we're zoomed, we're not going to be able to, oh no, I can see it. So basically, this is my browser. It can run JavaScript, and I can say console.log. I'll just say 1, and it'll print 1. So JavaScript works in the browser, and because you're in the browser, you might have things like window, which represents this entire screen, or document, which represents the current document I'm on. It cleaned it up for me, but it could be very long. And those things are just sort of environment features, whereas Node is a different environment for running JavaScript, where someone said, hey, JavaScript's getting better and better. What if we ran it on the back end? So we have Node here, and this is me running it interactively, and Node just lets us run JavaScript on the back end. But it's worth noting that if I type window, doesn't know what that is. If I type document, doesn't know what that is. But there are things it would know about that that browser JavaScript wouldn't know about, because, for example, like you saw with that prompt thing, you're kind of able to interact with a command line and a file system in Node, and you couldn't do that in browser JavaScript. But yeah, that's what Node is. Node ends up being, because of JavaScript's weird async stuff, where we've discussed a little, it actually ends up being very good for a backend, because one of the things that async thing allows it to do is that, unlike a standard language, which would say, okay, I'm going to speak to one person at a time, and when I'm done with them, I'll speak to the next person. JavaScript is really good at saying, I can speak to 100 people at a time, and it often can't actually speak to them at 100 at a time, but it's this idea called concurrency, as opposed to parallelism, where parallelism is the idea that you can do multiple things at the same time. Concurrency is the idea that your language is designed so that if you have the capacity to speak to multiple people at once, you can, but if you can't, it will like form a line like normal, but basically the language adapts to how many people are trying to interact with it, more or less. That tends to be good for a server, because servers often get, they could get an incredible load. They might normally have a very small load, and so Node works well with that. But we're not going to use Node for our backend. We're just using it as an environment you have access to for JavaScript. But yeah, so let's stick to this environment for now, and I'm trying to make it a little bigger in case we need to see. We're going to first overview intro to JavaScript a little, and just sort of discuss some basic ideas that you probably saw in pre-work, but maybe we'll discuss them in a little more depth. But before going on from here, does anyone have any basic questions about the history stuff? Not that it's necessary, but just any questions about it.
Yeah, so do the most big companies, like I guess you say Google and Facebook and like YouTube, do they normally use JavaScript?
Yeah, absolutely. So you can't
Okay.
have interactivity on your website without JavaScript. And so a website like IMDb, theoretically possible without JavaScript. It's just information, right? And links and pictures and things like that. But think about a website like Gmail. Gmail is fundamentally interactive, right? How would that work if it was just information? Basically, you'd have to click a link, and that would send you somewhere, it wouldn't work. You want to be able to, so basically the whole idea of like a web app, a website possible without JavaScript, a web app not possible without JavaScript. App being that word that means, okay, we have some real interactivity here. You can't get away without JavaScript. That said, JavaScript updated over time. And the amazing thing about something like Gmail is that Gmail took advantage of every feature that was added to JavaScript as it was added. So the Gmail source code, from what I understand, is really like it's using really old, weird features just because it has to, because it started with that. And they managed to maintain it, but it's probably somewhat of a nightmare compared to what you get to do in the modern day with something like React. They don't have that luxury because they started that project in like 1999 or something.
Thank you.
Yeah. So any other general questions about this? I will say it's not so important, the history stuff. I just like to contextualize, but really my attitude is that once you're in a language environment, either Node or the browser, you get to start thinking just at the language level. And that's something you can actually understand, where basically you want to be able to write a line and say, I know what this is going to do before you hit enter or before you execute it. And if you predict correctly what it's going to do, you can say you understand the language. And just the more and more features by which you can just look at the code and say, I know exactly what that's going to result in, the more you can say you understand the language. Cool. So yeah, let's start with that intro stuff. And eventually we're going to let you guys guide this a little more when we get to like the intermediate stuff. But for now, let's talk about the essential things. So I got this file playground.js open. I like to call files playground when they do this because it's just, a way you're just sort of testing out features. And that is an important point about, this program and being a programmer in general, which is looking at documentation. That's not a real source of truth. Running code, that's a source of truth. So if I were to write, let x equal 1 + 1, and I see Quokka's not, is Quokka running? Why? Tell me, Quokka. Because I have to like print it. Okay, I have to say x. So yeah, it's saying x equals 2. Let's say this said x was 3. Documentation would say that's wrong. Anyone who knows anything about math would say that's wrong. As far as the computer and the compiler or interpreter, whatever's running this code, as far as that's concerned, that if it says it equals 3, it does equal 3. So that, in this case, that would mean there's an obviously major serious bug in the system. But basically, you trust your compiler. When it yells at you, you are wrong. When it tells you a result that seems wrong, you must have done something wrong, and or rarely there's an actual bug in whoever created that software, that is Node or Python. But yeah, the ultimate source of truth is what runs, what actually happens. But at this point, languages tend to be, bugs like this tend to get figured out pretty quickly over time, or after not much time. I forget what it is, but there's an old programmer joke from like the mid-90s about how in Intel, on Intel CPUs, 1 + 1 equals like 2.000478182, because they had a weird bug like that. But nowadays it doesn't equal that. Cool. So we're going to talk about data types first. As I see it, data types are the essential thing in your computer or in a programming language. Before you ever get to manipulating data, functions or algorithms, whatever you want to call them, you have data. And data is how you represent information. And there's usually different ways to do it because, the computer might only care about 1 and 0. And when the computer wants to say the letter A, maybe it calls it something like that. But that's not very human readable. So we have these languages that allow us to think at this higher level. So there's 2 ideas here, primitive and complex data types. First, we'll talk about primitive types. But the main difference is that a primitive type evaluates to itself. A primitive, it's sort of like if you were to say, what is 1 + 1 equal? You would say 2. And then I would say, well, what is 2 equal? You would say, well, 2. I mean, I can't simplify it anymore. And that's what a primitive data type is. A primitive data type cannot get any simpler than its current representation. And that's what makes it primitive on some level. It's the bottom level at which the computer either says that is a reasonable string or that is a reasonable number, or I have no idea what that is, so I can't run this. So yeah, strings. Here's some examples. Let's just copy them over. So yeah, a string in JavaScript is generally contained between two double quotes. It can also be contained between two single quotes. I think Python does the same thing. That's just a choice there to say, and you see when I click save it, I have this thing called prettier running, which is just automatically going to format my code. So it made a choice for me. It wants things to be double quotes by default. But a string is just a way of representing a bunch of characters. Notably in JavaScript and in Python, if you just had one letter, that's still a string. There are some languages like C, for example, where if I just had one letter, I would represent that with single quotes, and that would be a character. And if I wanted a string, it would be double quotes, and that would represent, multiple. And I couldn't write something like that because, single quotes could only contain a single character, but JavaScript is not like that. It only has this idea of a string, no specific concept of a character. Character is just a string of length 1. As you see here, part of the reason for that double single quote thing is so you can do things like this. So similarly, I can have single quotes on the outside and double quotes on the inside. And my formatter should probably leave that alone. Yeah, because that's a legitimate use of, one versus the other form of quotation mark. Finally, we have these backticks. The backticks are a modern invention. So what you see above is an example of everything before ES6. Below is what we would consider a modern, cool, this is a nice to have feature that Python gives you, what we call string interpolation. So string interpolation basically means you can evaluate an expression of code, whether that expression is, a variable or, adding two numbers together. You can evaluate some code within a string. It will evaluate it, get it to its simplest form, and then turn it into a string, and then give you back the whole string. So before that, you would have to write something like this, where you would say, sorry, originally you had to write something like this. Notice I'm including that space here, and then I'm saying plus to say concatenate strings, and then probably in parentheses I would have to say 4 plus 44, and I would hope that would work. But in the case it wouldn't work, I would have to write something like string, which is also a function that's going to cast anything else into a string. Casting being a term that means to go from one data type to another explicitly. So this obviously doesn't look as nice as this. And so, this is a nice modern way to do it. And you'll see it most often interpolation when using variables. So we have some variable, and then we can put it right in there. As you see, it's saying, I'm going to take out this console.log because we just want to see what it equals. Oh, I was hoping it was going to show me. Well, let me drag this over a little so you can see it. So yeah, exactly. Interpolation is very useful for this. It'll often even work nicely if you have like an object. So if I were to have an object with 1, 2, what am I talking about? Object. Let me just do an array. I'm going to have an array with 1, 2, 3 in it, and it was able to print that out, and that's nice. And maybe you just assume this stuff is for free, but it wasn't always for free. It used to be pretty annoying to have to print out everything in your array or print out everything in your object. So this stuff tends to be nice. And then importantly, strings are immutable. So that idea will come up more in the future. Maybe you've heard of it, maybe not, but there's this idea called functional programming. And what that boils down to is basically recognizing that often you have this idea of mutability where things can just change. You can just say, my array first element, you can just say equals 44. You just change it. And sometimes that's not great. Sometimes you want immutability because it makes things more predictable. So Notice this name thing. This is silly, but basically it's complaining because JavaScript used to have something in it called name. So I'm going to change that to X, and now it won't complain. But right, exactly. So here I have this variable X. I'm calling it Benjamin with a lowercase everything, trying to update the first element to B. And normally we can access things like this, so I should be able to. But when I print it, nothing changes, and that's because strings don't let you change them. You know, in a different language, maybe this would actually cause an error and say, hey, what are you trying to do here at all? But basically a string can't be changed after it is created, and that's a very purposeful move. That has more to do with like the underlying implementation, but essentially strings were mutable in certain early languages like C, and people learn over time and learn, oh, there's actually a big problem with that. There tends to be big security flaws with strings being able to change, because you can just, you know, it's not worth getting into, but there's weird problems that can come up. But that's okay when something can't change, because immutability doesn't mean you can't, it means you can't change that variable, but it doesn't mean you can't create a new one or even reassign the same existing one. So here I have const name equals Benjamin, and then I can create a new thing called proper name. We're going to change that to X so it stops crossing it out. And I'm going to say, okay, get the first value in Benjamin, then make it an uppercase, and then get, you know, slice is going to take, is going to return me a copy of that array starting from that index. So get me the rest of it, and then add those two together, and the final result will be Benjamin. I guess I have to do console.log if I want Polka to show me it. Even then, it's not showing me. I don't know why. But if you hover over X, I'm not sure why it's showing me it sometimes and not other times. Maybe that was a mistake to use Quokka for that reason. But rest assured, this will equal Benjamin outright. I believe if I run it, we're going to see some stuff. Oh, it hates what I wrote. Oh, right, because I already declared X. Okay, so it is being reasonable there. It doesn't like that. Can't declare a variable twice. Now we're seeing Benjamin as expected. Yeah, I should not have blamed Quokka. So yeah, so as you see here, we can use, even though it's immutable, you can use these helper methods, a method just being a function that's essentially attached to an object or piece of data. So you call it with dot something. So we use these helper methods to create something new. And you could see we could even do something like if let's say we had instead of const y, we did it let y. Well, then at that point we could reassign y. And in this sense, it's almost like I did update it, but I didn't exactly. And that whatever the underlying representation of Benjamin is over here, wherever that is in memory, that didn't get changed. Instead, I just made this variable point to something new, which was created out of that original thing. Cool. So I'm just going to start pausing for like 5-10 seconds between these things, because if you do have questions, I do want to hear them. But otherwise, we can just sort of go through this material, and I'm going to check how much time we have in the calendar. If anyone has questions, now would be the time. Okay, we have another 2 hours, it seems, so we have a fair amount of time. We'll take a break in like 20-30 minutes. But it sounds like you guys are pretty good on strings. Some of the stuff maybe we won't even write. We'll just sort of look at. So we have numbers here. In JavaScript, there's only one type of number. There's not integers and floats. There's just numbers. So a number could be 0, or it could be 5, or it could be -5, or it could be -5.12345. And then maybe you have or haven't seen this, where I could have something like, you know, I could end any number with E and then 10 or something, and that's saying something to the power of 10, or sorry, times 10 to the power of, if it was 4, this is saying 1.25 times 10 to the power of 4. Most people never use this, but it's a form of scientific notation. Scientists use it, I guess. And it's also how JavaScript will start to represent numbers as they get bigger and bigger because it can't fit them all on a screen. What else? It is worth knowing about things like part of how numbers work in JavaScript and in most languages is you'll have a few other concepts like infinity and negative infinity. These actually end up being useful because let's say you had a list. So let's say I had this list of, const nums equals an array of 4, 44, negative 72, 100. And let's say I task you with finding the largest number in here, right? Well, I could say something like, if I want to find the largest number, I need to start with a value that I'm gonna, I'm gonna start with some kind of bookkeeping variable, which I'm gonna say current largest. And every time I go through the list, so basically I would have something like for let num of nums. We'll get into some of the syntax a little more if it's unfamiliar right now. That for now. So I would say for let num of nums, if num is, so we're trying to find the largest element. So I say if num is greater than current largest, then current largest equals num. And at the end of it, num would, current largest. At the end of it, current largest should have the largest value, right? So that works. And you'll see here, I said current largest was 0. But what if I had all these negative and I wanted to know the largest one, right? Well, current largest is now 0 because I said my starting point is that my starting point is 0. And it turned out everything I saw from there was actually smaller. So that doesn't work that well. But that's where stuff like negative infinity come in, because negative infinity is always going to be smaller than any number. Infinity is always going to be larger than any number. And it's basically useful in this case and probably no others. There's also this, which you might want to know about. Nan stands for not a number. Ironically, there's this, there's a built-in, I guess, operator in JavaScript called type of, which given a value will tell you its type. So if I were to write, I guess, console.log type of nan, it's going to tell me it has type number, which is funny because it stands for not a number. But nan is a number, where basically if you ever tried to say, if you were trying to let's say you were trying to cast, let's say you had a function. It's called parseInt. ParseInt is an actual function in JavaScript. If I give it the number 10, it's going to, it's the other way around. Basically, imagine you had a function that given a number returned its string representation. No, sorry, given a string represents its number representation. So if I had the number 10, and I can probably write something like number 10, and that's going to be a number, exactly, right? So what if I give it in a nan? So nan is used to represent situations where a number is expected, and we want everything this returns to always return a number, but there's no good number, so we return nan. Yeah. But just sort of details. So any questions about numbers in this sense, or type of, because we included that too? All pretty.
I kind of get confused. Sorry. So when you said type of nan, why does it show up as number?
Right. So let's say I said type of 1. That's a number, right?
Yeah.
So the question is, everything has a type. If I said type hello, it's a string. So the question is, what is nan? What's its type? It's a little odd, but like if I say what's the type of infinity, Well, infinity counts as this world called number. Nan, even though it stands for not a number, it's the thing of type number used to represent things that aren't numbers.
Okay, so nan is not a primitive type, so it has to be some kind of type. And then we just decided number then.
Yeah, no, I guess number is a primitive type. Nan is a member of that
Yeah,
primitive.
yes, that's the same.
So if I were to say like, if like in TypeScript, you have this word called type. So if I were to say type number and define it myself, I could say, I mean, I couldn't do this because it takes forever, but I could say, oh, a number is either a 0 or a 1 or a 2 or a 3. And obviously, you know, that's not great because you couldn't ever fill out all of them. But at the end of it, you would say, oh, actually, a number also includes this word called infinity, and it includes something called nan. And those are just, you know, you can think of nan, we're going to get to this idea of null and undefined, essentially. Nan, null is meant to represent a non-existent object. Nan represents a non-existent number. You just end up using it a lot less than null because there's rarely a good case for, you know, setting something to not a number when you could just set it to 0 or negative infinity or something like that.
That makes sense.
Yeah. Cool. And as you'll see, type of always returns a string, and type of is a little odd because you might expect that there would be parentheses around there. Type of is not a function, it's an operator. So just like most operators, if I have 1 plus 1, well, 1 is an operator, it's a binary operator. But there's such thing as a unary operator. So if you see -1, that's actually saying apply the operator minus to the number 1, and that results in -1. So it's sort of like the equivalent of saying -1 is the equivalent of saying 0 minus 1, but you just leave off the 0. So type of is like that. It's actually an operator, and what it takes on the right is anything. So I don't even know what it's going to think of this. And a lot of times you just kind of have to experiment to find out. So yeah, you might be surprised by that. Maybe you thought it would say it was an array, right? But I believe, as it turns out, virtually everything that's not a primitive in JavaScript is an object. So an array is basically just it's supported syntax wise, but under the hood, it's just an object. And in general, that's kind of all that exists. Like, I wonder if I had a function here, what it would think that was. Okay, it does think it's a function. That lambda symbol usually means function. Cool. But yeah, type of, oh, sorry, I wanted to write type of. Okay, it does know a function is a unique type. Good to know. But yeah, moving on from that, we have Booleans. So you've seen true and false. Notice they're, you know, lowercase in here versus Python. You might think there's not too much to discuss here, but I think there's actually what to discuss we probably haven't introduced you to yet. So the first one that's pretty important is what we call short circuiting. So you may have seen this or encountered this before, maybe not, but basically, imagine you're a computer and you're trying to understand the phrase true or false, and maybe this one we'll make it more complicated. It's going to be false and true, and these could, you know, be variables at some point, but this is what it's going to result in. So does anyone want to take a stab at how, imagine you're a computer, how are you interpreting this?
It evaluates true first, as long as it's true, and it won't evaluate the second part.
Yeah, exactly. So you're getting right to the answer, but exactly right. So let's say it didn't have this idea of short circuiting. The way the computer would work would say, okay, true. Okay, true evaluates to true. I'm done. True or, okay, well, I have to evaluate the other side. What's false and true? Well, that's false. And now my expression is true or false. Well, one of those is true. So I just say true, and then it results in true. But the nature of short circuiting is it says, okay, my first thing is true, and then my next thing is an or. Whether this is true or false does not matter. it's going to result in true, because if at least one thing is true, your OR is true. Similarly, if I had false and, the minute it sees this false, after seeing the and, it says, well, you know, that's got to be false, because if at least one thing is not true, that whole expression has to be false. And so it doesn't even look at the next thing. So we're going to put a pin in that for a second, but that idea is going to come back in a moment. This other idea is truthiness. So supposedly truthiness as a word was added to the dictionary with Stephen Colbert, because he had it on his show before his current late night show. But that idea of truthiness, or something being truth-y, has existed in programming since the beginning, which is basically, you know, you have this idea where, you know, something's either true or it's false, and that is either true or false. But what about the number 1? What if you had to give this a true or false value? And in computers, you often have this thing where you're implicitly or sometimes explicitly converting something from one type to another. So if I were to say, if true, you know, console.log hi, prints hi. Well, what if I said if 1? Well, that still works. What if I said, you know, kind of anything? What if I had a, you know, a list, whatever, a string here? If I had an array, oh, even an empty array, it seems, but certainly an array with something in it. So there's this idea of truthiness in the sense that values will implicitly be cast to something that makes sense generally in a given context. And so things can stand for true or false. And we could look it up on MDN, but the basic ones are what you would expect, where if it's a 0, that should be false. If it's nan, I imagine that's going to be false, right? If it's null, it's going to be false. It's undefined, it's going to be false. And there's certain basic things like that that are just, you know, because they represent nothing, they stand for false, and everything else is going to stand for true. So even, you know, if I do negative infinity, that's going to stand for true just because it's not 0. And 0 is the only value in that world that's going to stand for false nothing. Yeah. So basically, how do these two ideas come together? Truthiness, which seems kind of pointless, and short-circuiting. Well, you'll see a pattern like this a lot in programming. It's become less necessary with certain modern features like, what do you call it? Like function defaults. But basically, you can say something like this, 1 or false. I'm going to just give this I'm going to store it somewhere so I can see it. So if I say 1 or false, it's going to look at this left thing and say 1, that's truthy. So I'm short-circuiting. I don't even look at the rest of it. But importantly, x doesn't equal true at the end, it equals 1. So this is maybe not intentional, but as a result, you can use or and to kind of collapse the other values besides true and false together to get the value you want. So a common example would be something like this. Like I said, you'll see it less now because of default variables, but basically it used to be the case that you would pass in a variable called name, and name could be anything, including undefined. So if I called it like this, name would have a value, it would have the value undefined. And so what this does is it says, okay, that variable name, I want it equal to, first evaluate what name is. If name equals anything I like Sarah, leave it. It's going to equal Sarah. But if it's going to equal an empty list or undefined, or sorry, an empty string or undefined, that's going to evaluate to false. Because it's an or, we'll move on to check the next one. And then JSON will be the default. It is true that in the modern day, you would generally write something more like name equals JSON, and then in the exact same situation, it would figure it out for you, because that's what a default variable is doing under the hood. But we have this idea And then you could also do it with and it's a little hard to show you an example of this right now, but the reason I want to introduce it is that eventually, I mean, the whole reason we're learning JavaScript is because eventually we're going to be doing our front end stuff in JavaScript. And the main way to do front end these days, or one major way that I like a lot, is called React. And React actually ends up taking advantage of this stuff a lot, where if I were writing some React, I might have a component that looks like, my component, ignore, any red, but let's say I have something called my component and I want to render this, right? So normally I would return my component, but I could say something like, oh, actually, if my component, how might I say this? Like, in terms of the or, well, something you see a lot is you'll see something like, you might have some variable that says like, let is still loading equal true. And then I would say something like, is still loading and my component. So what that's going to say is that if this is false, we just end there. It never happens. But if this is true, we're going to return that component. So as you can see, that's a useful thing. If you're building a website, you might have certain variables in which you say, what's the status of this? And without this, we would have to say something like, if is still loading, return my component, else return null, because null is something React understands. So we could write something like this, but this is that much more concise and just fits in nicely with the way people generally write things in React.
Ben,
Yeah.
if you go back to the JSON example, could you put that back in the editor for a second?
The JSON example?
Yeah, the JSON is cool example that you had.
Oh, yeah.
I did notice a change when you moved the JSON from line 2 to line 1. It actually gave a different output. Actually, I'm sorry, I'm looking at line 6.
Okay, you're saying,
So line 11 doesn't show Jason's name anymore.
yes. Okay, so, yeah, right. Good point. So, they aren't exactly the same, as it turns out. If with this default variable approach, and obviously I could say, is cool 1 versus are they cool 2? So if I do it with 1, we're going to notice that we have fine-grained control over how things work. Where basically I can say, I'm getting this thing called name. If it's empty, that's going to be false. If it's if it's undefined, that's going to be false. Empty string, that's going to be false. Otherwise, and in both of those cases, JSON, otherwise it is what it equals. In this second case, I think we have a little less control over it, where it's, no, it seems to be the same.
If
No?
you look at the output on line 7, the blue text,
Yeah,
that second one off of line 11 doesn't show Jason's name. It just shows the empty string.
okay. I see this, right? And
Yep.
now what's different?
So it put in used, are they cool 1
Here?
Yep.
Okay,
for all 3.
okay,
So looking at the blue text at the end of line 3, it shows Jason, Jason, and Sarah.
right, okay,
How it's auto resolving that?
yeah.
If you do it with the second function, it's Jason blank and Sarah.
Right. Okay. So it would seem to be, you are right. I'm surprised. Then why is it returning this here? I don't know. But it would seem to be that when we
That's just a hard-coded comment, so it's not going to change JSON
Oh,
on
good
line
point.
11.
Yeah, I'm getting
It's a
confused
comment.
between my own. Good point. Good point. Yeah. So you are right that there's a difference where in this default case, it's only if name is undefined that it gives it the default value. Anything else, including a falsy value like empty string, it still counts that as a real input. So yeah, there still is a use for this or thing. I would say in general, you're gonna like, it makes sense that you could always write logic in which you're sort of like what we call sanitizing the input, where like you might have this input name, and you could always just write here like if name is has this quality, do this. If name is this quality, do that. But it is, yeah, that is a good point that they're not identical. But the goal is just that you see how truthiness and short circuiting combine in this, this way of using ors and ands to sort of build up the right version of a variable. Okay, any more questions about that? Okay, I'm gonna guess no. Okay, so here's something I added, just a little snippet type thing to discuss, because I saw some discrepancies with people writing their code this morning. So there's actually these, in JavaScript, or sorry, in Python. Remind me, what does it look like in Python? If you want to have a variable, you would say x equals 1, right? And then similarly in Python, if you wanted to compare two variables, like let's say I had x equals 1 and y equals 2, I would write x equals y, right? Is that correct?
If you want to compare it.
Yeah, exactly. So this double equals means comparison. And in Python, there's no such thing as triple equals. So this is a weird little thing in JavaScript where, let's turn this to JavaScript now, where I'm going to have, I'll just use let's, it doesn't really matter for right now. We'll get to that difference, but I have an x and a y variable and I want to compare them, right? And let me actually console.log what they result in. So I'm going to say console.log. If I say x equals y, it's going to be false because they're not the same, right? And if I say x equals y, same, they're false, they're not the same. So why these two different things? Why equal, and triple equal? Well, this is another example of what I consider to be a terrible design decision in JavaScript. But we mentioned before how JavaScript has this idea of dynamic typing, right? So if something has a value, so an example of dynamic typing is you might know that if I have an A and a B, I can add them together, and that's going to be concatenation. And similarly, if I have a 1 and a 2, it's going to add them together and I get 3. But as you might have saw for a second there, we have some weird situations where what happens when you add a number and a letter? Well, most people like Python will yell at you about this and say, hey, I think you did something wrong. JavaScript has a weird philosophy which says, it kind of allows everything, tries to make everything work. It's a peacekeeper. And so it'll basically absorb nonsense and try and make sense of it. So when you try and add a number to a letter, it basically says, okay, well, I want to add these two things together. It's either addition or concatenation, not both. So can I turn a letter into a number? No. Can I turn a number into a letter? Yeah. So this results in the string 1b. And that'll be true even if it was like this. That's not going to try and cast A into nan. But you'll see weird things like that sometimes. But basically you have this idea of, dynamic types, which means that something has a type, but we're never explicit about what it is. And as a result, it can kind of change on the fly. And as a result, it's not terribly useful. So this is what the equal versus triple equal thing is. So this is, again, terrible. So I have 1 and 1, right? 1 and 1 equal each other, and they also double equal each other. Now, what about this? Put that back. 1 and 1. Okay, well, they double equal each other. They do not triple equal each other. And in my opinion, it's almost never the case that you want to compare two things of different types and say, oh yeah, they're the same. It's just one's a number and one's a string. So basically never use the double equals, always use the triple equals. It's pretty annoying. it's just one of those weird artifacts of JavaScript that you have this double equals that, that's going to be useful in some tiny, tiny fraction of situations. And yet it's taking up this, very useful, set of characters, double equal. But just get into the habit of when you're in JavaScript using triple equal. Yeah. Someone said something?
What happened?
Is someone trying to speak? No. Okay. So yeah, that's your double equal, triple equal. And these are all these little things where like, maybe you've encountered some of this, maybe you haven't, but they're just these caveats of JavaScript that are not really features. They're just there. They're features that you don't exactly want, but you might have to know about at times. Okay, so finishing up our discussion of primitives, there's two more. Undefined. Undefined equals itself. If undefined is a type, so if I were to write, I believe so at least, let's find out. If I were to write type of undefined, I believe that's going to return the string undefined. Yeah, so the type of undefined is itself undefined. Undefined is both the name of the class of type and its only member. And it's there just to describe things that don't exist yet. So if you were to say let x and then console.log x, x was never defined. And there's, sometimes reasons why you want to initialize a variable without defining it. Similarly, if I had a function and I'm going to give it a value, input or something, and then I'm going to say console.log input. This is probably the most common situation why undefined exists, because if I were to try and call that function, if I called it with 1, input has a value. If I call it, because of dynamic typing, I can kind of give it any value. It doesn't care if it's a number or a string. But if I give it nothing, it's undefined. So undefined is just there to say, no one ever gave this variable a chance. No one ever gave this variable a value at all. And yet it's useful at times. And this is now we're going to compare it to null. So null is almost identical to undefined in its behavior. It's also falsy. You might say, why does null even exist if undefined exists? I don't know that there is a great answer, but in many languages, in many languages, undefined is not even an option. But in most languages, you will have a concept like null or nil. And that comes from the world of object-oriented programming, and it means this object doesn't have a value. It might seem like more or less the same idea, but basically, if I were to have something that should be an object and it doesn't equal anything initially, I might say, let object equal null, and then maybe something later is going to happen, and I'm going to say, okay, that object actually has this value. But it starts out as null because it's easy to compare things as null. You'll often get something called a null reference exception when you're programming. So you'll often get an error if you try and do something like object dot, if I try and do object.x, that's going to work here. But what if I never wrote that? Well, it's going to have this property because x doesn't exist on it. And the way it knows that is because it doesn't even have to look at .x. The minute it sees that object is null, it says, well, there's nothing on there. So these aren't necessarily totally unique ideas, but basically just like 0 represents the false value of numbers, false represents the false value of Booleans, empty string represents the false value or sort of the non-existent value of strings. Undefined is the non-existent value for variables. Null is the non-existent value for objects. And the truth is there are a few more primitives in JavaScript, but they aren't really worth discussing. They're just later inventions. I believe there's this thing called symbol, and that counts as a primitive. I never really learned much about how symbol works, but the basic idea of a symbol is that it's a totally unique thing. So if I were to create this is sometimes a desired thing that, let's say, I'll call these A and B, so it's a little less confusing. In many situations, if you created an object with the same exact value, you would expect that they would be the same. But with symbols, two things are never the same, I believe. Like it's impossible for two symbols to be the same. Even if I wonder if I remove this, it's always going to be, they're never the same thing. And that's useful in rare cases, but we'll never really touch it. Cool. After this, we're going to start talking about complex data types. When I say complex, I mean it's made up of primitives, or just like in Unix, you either have a file, which is primitive, or a folder, which contains, files, which are primitive, or other folders. A complex data type either contains primitives or other complex data types. So it's really a container more than a thing. But before we get into that, do we have any more questions about primitives? And actually, after this, we'll just take a break and come back. Does that sound good, Zainab?
Yeah, sounds great.
Great. So any more questions about the primitive stuff? And also, feel free if you don't want to say it to me directly, but you can put it in the chat or message me privately. But like, we've gotten feedback in the past that this lecture is a little too low level compared to what you already know, given that you've done the pre-work, and we're trying to modify that to some extent. We're going to get into that. So like, probably have to move a little faster for that. But I do want as much feedback as I can get about if this is too easy, not easy enough, maybe just right, what kind of topics you want to see in this, because we can't cover the whole language in, even in 3 hours, but we certainly don't want to just reiterate stuff you're already familiar with. But yeah, any questions about the primitive stuff or no? We're feeling okay. Okay, sounds like we're okay. We're going to take a 15-minute break and come back at 9:45. Does that sound good, Zainab?
Yep, sounds great.
Great. See you all in a bit.
See you.
What was that? Hey, I see I'm like 2 minutes over, but hopefully you enjoyed a little bit of a longer break. Are you guys ready to come back? Is everyone here? Or did I mess up and it's only been 7 minutes and I'm confused? Can anyone can someone tell me what's up?
What's up?
Okay, we're back.
What's
I'm gonna say we're ready to go. I just want to make sure I didn't miscalculate the time in my head. We stopped at like 9:30, right? And it's like 9:45 now.
Yeah, you're good.
Okay, we're good. Let's do this. Hopefully everyone is back. If not, there's only so much you can do when things are remote. Cool. So where we left off is basically intro to JavaScript stuff, where we sort of discussed primitive data types and some details around that. And no one really had questions, which I hope means that you understood it more or less. So what's left for the rest of the lecture? We have, a little over an hour, kind of a fair amount of things to go through, but not all of it necessary. Like I said, this lecture can't be long enough for everything. So it's really a matter of what you guys want to hear about. We're going to talk a little bit about complex data structures, which are things like arrays and objects. And I just wanted to mention stuff like sets, where even though arrays and objects are the core of it, JavaScript eventually added this thing called a set, and it has a few other data structures like this that are built in, which you won't use very often, but once you get to the interviewing stage, some of these are useful to know about because they kind of like give you certain functionality for free. And then we're going to talk about functions and how functions work differently for primitive versus complex data types and why that's like, a big distinction. Then there's a bunch of intermediate concepts to discuss. But the main thing is this thing called syntax sugar. You probably never heard this term before, but I like it. Syntax sugar basically means when a feature is added to a language where you were able to accomplish that before, but now you just have a nicer way of doing it. And that's what describes most of what's been added to JavaScript in the last bunch of years. It's nice to have stuff. It makes your life a little easier, but it's not something that was impossible before. Whereas if you didn't have a for loop or you didn't have an if statement, you couldn't recreate that with other things. You just wouldn't have it. Okay, cool. So let's go up a little bit. Where does this start? Kind of long. Complex data types. Okay. So we have arrays. You've heard of arrays, or you've seen arrays. You've used arrays. Arrays work like you would expect. The important thing about complex data types is that what makes them complex is that they are these containers, and as a result, they are mutable. So generally, you can change what's in it. And so like here, unlike that example with a string, if I change the first element, it actually did change it. There's also lots of methods for it. So just like with strings, we're often going to do something like this. I mean, push is a pretty obvious one, but basically when you're working with an array, there's no reason to do everything from scratch. There's lots and lots of good methods already. So at the very least, push will add something to the front, pop will take it, push will add something to the end of an array, pop will take it off of the end. Shift will add something to the beginning of an array, and unshift will take it off of the beginning. And those two things alone are generally enough to manipulate an array however you want. Cool. I think that's all there is to really say about an array. Arrays in JavaScript they can technically take anything, so they don't all have to be the same thing. I could have an array with Monday, 1, Wednesday. Some languages would not like that, but JavaScript is okay with it. And yeah, there's not much to say except that arrays are your basic ordered container. And your basic unordered container is an object. So let's just copy all of this. So I'll delete that for now. So yeah, an object is different from an array, and then an array, essentially the keys of an array, or You can think of them both as being key value pairs, but the keys of an array are 0, 1, 2, 3, 4, and they're always going to be in that order. And because of that, you can always know what the fourth element of an array is, for example. An object is not like that. An object is a more generalized version of that, where the key can be anything. And this is useful because sometimes if you were to try and represent something as an array, it would be relatively sparse. So let's say you had a database and you just had a bunch of, users in your database. They might have some random IDs, and you wouldn't want to have, empty after empty after empty after empty. You just would want to have the people who exist and their IDs. And importantly, it doesn't have to be a number. It can be, and it most commonly is, a string. I mean, this would technically be that. But shorthand, you don't have to put the quotes in there, like seen here. And so an object is just a way of associating a label that is unique with a value. And that value can be anything, including, as you see here, I mean, sometimes it's a primitive, but sometimes it's another object. It can be an array. It can be anything that you could store as a value. I mean, it could even be a function. If you really wanted to, you could say, and that's totally fine. I think it's complaining because why is it complaining?
You changed 457 to area.
Ah, yeah, good point. I'll undo some of those. But yes, so basically you can use this bracket syntax to look up something from an object. That's always going to work, but very often when we have a key, it's not a number or something weird, and it really can be almost anything that can be unique can be in there. But most often it's just going to be a string, and then you just access it with the dot syntax. What I want to say, notably, it is worth noting that keys have to be unique, and if they're not unique, then the latest one will overwrite it. So let's say I had 457 twice, and here I'm going to say John 99. You'll see that those values change, because even though I had something 457 here, I overwrote it here. And honestly, I'm kind of contradicting the idea that objects are fundamentally unordered. Objects are fundamentally unordered, so I think it's even worse than I just said, in that you never know, at least if you're writing it this way, you don't actually know which one it's going to take. So it's important that it always has something unique. Although I guess it's likely the case that that there is a guaranteed when you write it out explicitly in order, you at least know that the thing that is rightmost will overtake anything that already exists or is to the left. But the important one is objects have no fundamental order if you happen to be looping through them in some way. As you see, you can reassign a key's value, so it is mutable. You can actively change what's in age, and if you were to look at the entire database, you would see that indeed age updated there. I don't know if we could see it entirely here, but yeah, no, we can see it when we hover. But basically, this is not a case where you can only read from it like immutable stuff. You can both read and write to it directly. And this brings us to the point of how functions work slightly different in primitive versus complex data types. So again, you probably have noticed this, but maybe you've never been taught it formally, and there's certain terms that are useful to know. So we're going to take this example here, and we'll explain a little bit about what's going on here. I mean, I might as well delete this existing stuff. So yeah, we're creating a number called 42, or a variable, and then we have this function that takes a parameter num and adds 1 to it and stores it in that parameter, or in that variable num. And now we're going to call it with my number, and we see that afterwards the number it equals is the same. So why is this? This is what we call copy by value. So basically, when we call increment number my number, it's going to interpret my number. It's going to see it's the number 42. And then locally within this function, we're going to have something called num, which refers to something of value 42. But importantly, it's not the same thing as this. They're totally separate. And if we were to trace it, we would see like this has, you know, a memory address of, let's say, 4. And this has a memory address of 278. And the idea is they're just not pointing to the same bit of memory. So any change we make here will persist for the rest of this function. But once this function is done, this value num no longer exists. And so by the time we're back here, any change we made to num is irrelevant to my number. That is not true, however, when it comes to complex data types. So here's an example of a complex data type. We have something called my object, which is an object with name Tom and age 34. And unlike copy by value, this is an example of copy by reference. And notice this happens automatically with functions based on your data type. So I'm gonna, call my object with this function. I did approximately the same thing, right? I'm just accessing the age variable and updating it. And because object is passed by reference, object in here is the same as my object here. So when I modify it, even though the variable is different, it points to the same thing. So when I modify it, it's actually modifying the thing outside. References are kind of a weird idea, especially for you guys, because in a language like JavaScript or Python, you're never explicitly dealing with this idea of a value versus a reference. The language makes those decisions for you, whereas in a language like C, you have to be explicit about when something's a value or when something's a reference. But the basic reason for this is that when you're passing around a value like 42, that's pretty easy to copy over. Whereas an object, we don't know how big that object is. And let's say that object represents like the data in a DVD. If you have to copy that by value, every time you run that function, you're copying like 4 gigabytes of data just to run that function, just to make a copy of that variable. Whereas when you copy by reference, what goes in here is basically a number representing the memory location of that object. And what comes out here is the same memory location, so that when you modify it, you're modifying the same thing. It's not a new piece of memory. So hopefully that's relatively understandable. I don't know if that's the case. I mean, I'm curious about if there's questions about this, because this isn't a.
I have one question that's probably stupid, because it obviously works, but so you're defining your object with let my object equals, but then in your function, you're passing in obj, which isn't defined anywhere. So how is that passing in?
Yeah.
Like that.
Yeah, no, that's a good point. So there is this distinction where sort of like when I'm doing something, let's first look up here where when I'm doing something by copy by reference, I'm gonna create this little box where this little box to explain what's happening. So basically I'm creating this variable called my number, and I'm setting it to the value 42. So when my number is looked up, it equals 42. Then I have this function, and then I'm calling it, I'm logging it. So what happens when I call it? When I call it, I'm saying increment number, and I'm actually going to evaluate 42 there. And because it's copy by value, within the world of this function, because this is a function, I could give this parameter any name. And even if I gave it the name my number, it would be overwrite. It wouldn't be overwrite.
Yeah. Sorry, that was a dumb question. I need more coffee, I think. I understand.
No, it's totally fine.
Can you just go back down to the object one?
Yeah, we will in 1 second. Yeah, but the important point to note is that once we get to this point, num equals 42, but it doesn't equal the same 42. So then we're going to update it to 43, but then the function ends. That doesn't exist anymore. So my number is still 42. But yeah, when we go to the object case, let's walk through that same thing where.
Yeah, I totally see that now. But for whatever reason, my brain just didn't see you passing my object into the function below calling the function. I don't know.
But importantly, basically, because of this copy by reference thing, when I put my object in here, we now have this new variable object, but instead of object pointing to a brand new array, or sorry, a brand new object, it essentially points to my object. Really, it's just imagine an arrow from here all the way to here. It just points to the exact same thing. So it's not a copy of it, it's the same thing, and that's why changing it has the effect it does, whereas in the primitive case, it does not. So honestly, that's one of those concepts that, like, if you're getting a 4-year CS degree, you're allowed to struggle with that a little bit longer. You have like a month to struggle with that, and you guys have more like a day to struggle with that. So if we have any questions about that, let's dig into it, because it isn't obvious things should or would work this way.
I had a quick question. So in JavaScript and Python, you'll never need to specify that something's passed in by reference. It does it for you. So if I wanted to pass in 42 by reference,
You couldn't.
I guess
You couldn't. I'm gonna go into how you might accomplish something like that. But basically, right, if you were in a language like C has this concept called pointers, where I could say over here, I would say I'm actually not passing in my number as I don't even remember my C, but I would say I'm not passing my number by value. I'm saying, give me the reference to that number. And then in here, it would indeed change it. And then similarly, in C, if I didn't specify that I was sending in a reference, it would actually copy the whole object and be a separate object. But in modern languages, they decided that's annoying for most people to have to keep track of this idea of references, so we just make the decision for you. Yeah, but it is worth noting that if you want alternative behavior, you can have it. So, well, actually, you can't have alternative behavior for the first case, I don't believe. Oh no, I have it right here, right? So let's say we wanted it to actually update that number. We would have something like this, where we would take in that number, update it, and then return it so that we could set the original thing to it. So that's how you would accomplish the equivalent of how references work for a primitive in JavaScript. And then similarly, the way how you would accomplish copy by value for a something that's normally by reference in JavaScript is that we'd have our object, we pass it in. Did I copy the wrong thing? I did. Yeah, give me a second. We have our object. You see, I named it something more complex. But basically, we pass it in, and then the first thing we do is copy it so that we're not changing the original, and then we update it, and then we return the copy, so that you might have this new object, and it has the update, but the original one was unchanged. And this is sort of the core difference between doing things in a mutable versus an immutable way. The downside, or the upside to the mutable way, is that you're not wasting memory for no reason. The downside is you lose history, as in once you change something, there's no way of recovering what it was like before. Whereas an immutable approach to things says, I'm going to waste a fair amount of memory just creating new copies of things. But importantly, I didn't change the original. So I know I always have track of the original, and it makes it often very much easier to sort of track where something went wrong. When you never lose track of the original, you're always just creating a brand new updated copy. Okay, so any questions on that before we continue? Because after this, we've now covered, well, arrays and objects and functions as they're related. I should talk about sets for a second, but any questions about that world in general?
I have a quick question about objects. So doing the pre-work, I had an easy time going through arrays and manipulating them using the push functions and things like that. When I got to objects, is there an easy way to like add a new key value pair after the object already exists? And can you show us
Yeah.
what that looks like?
So let's say I have an object and it looks like this, and it will have X of 1 and Y of 2. It might be, compared to an array, it might seem deceptive, or it's deceptively simple how to add something, because instead of having a function like push, we simply say object, we open up the brackets. But instead of getting something that exists like X, we just say Z, or rather I could just say object.z equals 3. And now if I were to console.log object, it has Z in there. So it's like you can just describe, you can add a new key value pair to an object on the fly like that. The weirder thing is actually, how might you remove a key value pair? As in, let's say I didn't want X to exist anymore. What could I do? I could say object.x equals undefined or something, but it's still, the key is still there, right? So actually the only way to do this is another keyword that you don't see a lot, but delete. You can delete a key that way, but otherwise there would be no other way. But yeah, the combination of delete and just declaring new key value pairs is how you update an object on the fly. I think you're on, yeah.
Yeah. Okay. Awesome. Thank you.
All right, cool, yeah.
Pretty easy.
Cool, and in my opinion, those are the things, like, those are better things to spend our time talking about than a lot of these intermediate things, just because essentially everything we've discussed up until now are your bread and butter. They're the core of what a language can do. Something you learn if you take like a theoretical computer science class is that all a language needs is if statements and for loops, and it can do, and variables, and then it can do anything any other language can do. It's called Turing complete. It means it's as powerful as any language. And those are your three features: variables, conditionals, and loops. And everything else a language could give you is just about making your life easier, or making it, you know, easier to read or more efficient or something like that. But that's all, those are the only tools you actually need. I do want to mention this thing called sets. So by ES6, I think JavaScript added a few more things. So just like you have arrays, which are ordered lists, and objects, which are unordered key value pairs, you have this idea called a set. So I can say const my set equals, you have to use the new keyword here because we're creating a new object, and it doesn't have a, you know, a simple representation in the language like brackets or curly braces, but we're creating a new set. And then I could say, you know, it supports some things. So I could say my set.add 1, you know, my set.add 2, 3, and we can look things up. I'm sure there's a way to, curious if I said console.log my set, what it shows. So it shows the whole set. So why even a set? What's the point of it compared to an array? The main reason is this: a set will never add anything twice. So an array makes no guarantee, an object makes no guarantee that you're not storing a value more than once. An object sort of makes that guarantee where the key has to be unique, but with a set, it's more like an array where everything has to be unique. And the only reason this is really useful is because there's certain problems that you'll see in the interviewing stage where it's really helpful to have a data structure that you don't have to say, hey, does 2 already exist? If it does, do this. If it doesn't, do that. Instead, a set just handles that logic for you, and its end result will only be unique elements. So, just worth mentioning. Okay, so what we have left now is intermediate stuff. And even though I don't so I want to discuss this idea of syntax sugar, syntactic sugar. Basically, everything we're going to talk about from now on is something that was added to the language at a later point, and it makes your life easier, but it was always possible before. It's just you might have had to write it in a more cumbersome way. So yeah, the first thing we're going to discuss is variables. So you're probably familiar with some of these, or you are familiar with these. Variables are identifiers, or sorry, yeah, variables are basically a way of associating a string that you know about as the programmer with some value. And we use the word const when we don't want that value to change. So when I say const num equals 1, I'm going to get an error if I try and say num equals 42. You see, it's even giving me a little red there. Which is good, but it is worth noting that with const gets a little confused when it comes to complex types, or it just might not act the way you think it should act. Where if I have a const variable object, I'm going to set it to num1. You might think that this shouldn't work, that I shouldn't be able to say object.num equals 42, but I can, as in it's only object itself that is const. And if I were to try and change what it points to, it doesn't like that, but I can change object itself. If you're curious, there is a way to say you can't change object, and I believe that's within the object class. There's something called freeze. And if I were to freeze object, now, if I were to say object num equals 42, you'll see it didn't actually change it. So the only way to guarantee that an object is frozen in the sense that it doesn't change is not to use const, but to use object.freeze. Cool. And then the alternative to that is the let variable. So you'll notice that unlike this type error situation where you try and reassign a constant, if you reassign a let variable, it's complaining because it's seen these. If you reassign a let variable, it's fine with that. That's kosher because that's what let is for. And basically by default, start with const, and then when const is not the behavior you want, you move to let. But by default, it's nice to have variables be const just by default, because otherwise you can accidentally change a variable, or just you're opening up a variable to be changed. And that can often be an issue if you're like working with a lot of people, because you might, think, oh, I created this variable and this is one of those variables that is just not going to change. But then someone down the line, if you use let, they could change it. And they might not know that you said, oh, this is a variable that never changes, because maybe it's getting passed around a lot. Yeah, so that's let versus const. And it is worth for a second talking about this var thing. So var is what we used to have. Var is the original let. There was no const originally, so there was no way to guarantee that something wasn't reassigned. And var, just stands for variable, and it does more or less what let does, but here's the reason why it was replaced, among other reasons. If I were to type this code, I get an error, right? It doesn't know about name because name wasn't declared yet. This doesn't work. Name is declared after. And if I move this, I think actually I'm getting an issue because of X in part, but if I were to move this, now it does work because X was declared and then it works. So how does var work? With var, just gonna change that to X. With var, instead of breaking and saying, hey, I don't even know what X is, you never mention it, it doesn't exist anywhere, it just says undefined as long as you define it later. So if I do this, what? Now it equals 1? Very odd. That's wild. I don't even know why that is. But yeah, so I would hope that would at least break. Wonder if, there we go. Okay, it must be, X must be a special thing. So in this case, if I say var hello later, it'll say undefined up there, but otherwise it'll say I've never heard of hello, and then it's an error. And the reason is because of this thing called hoisting. So if I do this, that what we saw above here is equivalent to what's below here, as in it actually takes, anytime it sees a variable, it actually hoists its initialization to the top and then only assigns it in that actual place. And that's weird behavior because you're not expecting that. And sometimes that behavior makes sense. Like you probably noticed you can call a function f. I'm just going to make a function called f. And as long as I define it this way, this works. So functions are also hoisted in that their definition is pulled up to the very top of the file, and it makes sure that it can that it doesn't need to be defined previously. And that's kind of a good feature for functions, but it ends up being a very weird feature for variables. So for good reason, people avoid var now. One more example of a weird behavior of var. JavaScript by default, or at least var, does what's called function scope, whereas most of us expect something will respect block scope. So we're going to call two functions here, some with var and some with let. If we look at some with var, creating this variable called sum, right? And then within this function, we're creating a for loop. And that for loop is having a variable called I for the counter, and it adds it to sum. But here's the thing, once this for loop is done, I'm actually able to still access I. And that, in my opinion, is weird because you would hope that I as a variable only exists within the scope of this block right here. Block just meaning anything between two brackets, whether it's an if statement or a loop or a function. A block is a block. But actually the way that var works is that block scope is not respected, only function scope. So any variable you would create in that you only want to exist within a for loop or within an if statement actually lives in the entire function, and you can access it after. And it's the kind of thing you can avoid, but it shouldn't work this way. And with let, you get a reasonable good error, which let is block scoped. So when you create this local let that's an I, it's going to not exist once this for loop is done. And if you try and access it even within the function outside of that for loop, you get a real error. And that's the main reason we use let and const over var, that var has certain behavior that will just fail silently in a weird way. And we'd much rather that when we're trying to access a variable that we no longer reasonably have use for, we should not be able to. It should not exist anymore. We should get an error. And I think there's a bit of a lesson there in that when you start out programming, it's often common to see red and the compiler errors as like your enemy, but they're very much your friend, because the compiler yelling at you that something doesn't work is so much more useful than it not yelling at you and it actually doesn't work, but it just fails silently. And then it gets to production and it turns out you got this big bug, but your programming language was too stupid to tell you that's probably not what you want. So any more questions about the var let stuff? In general, just always go let const, forget about var at this point, unless you are on a legacy thing and encounter it. Okay, functions. So you're all familiar with functions. I mentioned a hoisting thing. So I'm able to call make full name here, even though I define it down here. That's just some dummy function I made up that is going to return a string containing the two parameters. That works. But then there's this idea of an arrow function. An arrow function, at the very least, is just a way of creating a function inline that looks a little simpler. So very often you have to make these small little functions, and it's nice to not have to write it all out. So an example would be something like this, where this is exactly what I just showed you, but instead it's inline, where you notice I didn't have to write the word function. And then I have this fat arrow, as we call it. And then notice I didn't have to say return either, because if it's on one line, just assume it's return. Doesn't mean I can't have a full function here. I could have just as well done this, and this works. But sometimes it's very nice when your whole function can fit on one line, because sometimes your function is very simple. And you'll notice that this function we created, this arrow function, is what we call an anonymous function, in that a function like this must have a name, sorry, like a function like make full name here, it must have a name. You couldn't leave out the name here. Whereas an anonymous function by default doesn't have a name. And if you want to give it a name, you save it to a variable. And another difference worth noting is that because you're saving it to a variable, none of this hoisting exists. So if you try and do it in this order, it's going to say, I've never heard of make full name. But a lot of people like that feature because this way you must declare something before you can use it. And that's kind of, that helps with the fact that you want to read a program top to bottom and assume the compiler is reading it in exactly the same way, and hoisting kind of breaks that rule. So this way we know you can't run anything unless it's been defined above it. Cool, yeah, so a big use case of these anonymous functions are in functions that we would call higher order functions. So it sounds like a pretty intimidating phrase, but basically just means the fact that you can pass around functions and we would say functions are first class objects of a language. So in some languages, you can't pass around functions like this, but in JavaScript, you can. In most languages at this point, you can. In Python, you can. But the idea is that you could just use an anonymous function as the input to another function. And we call that a higher order function because instead of having to make, I have this array nums. Instead of having to make one function called doubler and one function called tripler and this and that, I actually have this function called map. Map will take any function at all, expecting one input, and returns another input, returns an output. And map just takes this mapper function and it goes through each element of the array and applies the mapper and then returns you an array with all of those elements in it. And that tends to be useful. Similarly, we have things like filters. So I could just, because this returns a list, I could just, add this to the end here. And I could say filter. Well, filter is going to take an X. And I'll say if that X is divisible by 2, then I want to keep it. Okay, that actually is not so nice here. So I'll say as long as that X is less than 6, I want to keep it. Or rather, I want to say, I get confused. They basically filter whether, I think if you return true, so I'm doubling it, 2 is less than 6. Oh, sorry, I want to say X, I'll just say X is less than 6, right? Exactly. So this only if the value passed into here is less than 6. If this returns true, it'll include it in the list, otherwise it won't. So things like map and filter together, this was able to all fit in one line. If I wanted to write this out in kind of the old way, I would have to write something more like for let num of nums, let's just assume I'm calling it, const my new list, an array, and I would write something like my new list dot push what is it, X times 2. I mean, as you can imagine, it's more lines, it gets more complicated. I'd probably have to write something like, I'd have to put that if statement first, where I say if, I'd probably want to first do it where I say const new val equals X time or num time 2. And then I'll say if new val is less than 6, otherwise push new val, and it'd be the same thing in the end, but it's just longer than it needs to be, and this is a nice way of doing it. That's kind of all there is to that. Yeah, just an example of why it's more convenient. There is another difference between regular functions and arrow functions, and it has to do with the this keyword in JavaScript. But we haven't really gone into the this keyword yet, so we're going to ignore that for now. But basically, there are reasons why you will want to use the arrow function at times. And for the most part, you can just assume that, like, just like letting const are better than var. Arrow functions in some sense are better than original functions. Most of the time they'll function the same, but the reason why they were invented in part is not just this shorter syntax, but because they were able to add something new to the language that has slightly different and improved functionality compared to the original, which had these little issues. Okay, so we've touched on most of this now. Let's do the ternary operator. This is another one I like, similar to the using ors or the ands. This lets you put everything in one line in a nice way. So up here we have, our age is 24. I mean, these are just contrived examples, but basically I'm saying if there's something, then set it to one thing or set it to another using an if-else statement. And importantly, in order to accomplish this, I had to define it outside of this if-else statement. And so it has the possibility of having the value undefined, and it does until this runs. And then this is an alternative called the ternary operator. Ternary operator is mostly useful in this case where you want to set a variable, but it's based on a conditional. So you ask the conditional, and depending on the answer, you return one value or another. And just like if-else statements, ternary operator can be infinitely expanded upon. So I could say something like, if age is less than 21, then answer nope. And then this colon means otherwise, but I could say otherwise, if age, so let's say age wasn't less than 21, but I'm going to say if age is less than 28, then answer hello. And only the final one represents your else case of saying, and if none of those conditionals were true, give it the last thing. But basically, it's just a nicer way of assigning a variable based on some kind of conditional logic. And again, you'll see it a fair amount in React when we come to that. Okay, so let's do loops. Loops is something you're probably already familiar with. This is the original loop. Originally, this was all that existed. You had a for loop, which, had these, three things separated by semicolons where you have an original value, which you're declaring, and then you have a check value where you say, or a conditional where you're saying, is this true? As long as this is true, continue. And then you have an update at the end of the loop variable. So I imagine you all understand how this works. But you probably also all are familiar with the for of syntax already, but if not, it looks like this, where we have, what is that about? Who knows? Oh yeah, no, that's broken in my logic. I'll change that. But yeah, so here we have this list of numbers, and then instead of having to say, go through each and then referencing it using that index, this just sort of combines that where we're saying, okay, we know that this thing that we're walking through is a list, so I just want to get each one at a time. And this one up here, the standard for statement, it's actually still useful in that sometimes you'll be doing something where you don't just want to look at this element of a list, you want to look at this element of the list and the previous one and the next one or something like that. And when you have access to the index, you got to be careful you don't go beyond the index, but you can just easily check what's before or after in the loop, whereas in this approach, you can't. You're only looking at one thing at a time, but this will usually be all you need.
Quick question.
Yeah.
So is that the same as the example? So in the example, you have let num of my numbers dot length, and you just put my numbers there. So is that just a different way to do it?
No, I mean, I need to take that out. Where it says dot length is actually an error. I just left that in there accidentally. But my numbers, is an array, and length is a field of this. Is like because an array is an object, it's able to have methods which are functions or fields which are just values. And so dot length just represents the number of that. Dot length represents the, make sure we're taking it out of the right one. Yeah. Dot length represents like over here, it represents how, just the number of elements in the array. So the problem with doing this, which this will reveal a bit to us, it's complicated what it's saying, but it's essentially trying to tell us it's not iterable. As in, I have no idea how to walk through the number 5 or something, whereas it does know how to walk through an actual array. Which brings us to our next point, that this let of thing is actually pretty powerful, and that it doesn't just work for arrays, it works for anything that is iterable, meaning anything that can be walked through. And it's not just arrays that are iterable. In fact, JavaScript makes it so that you can define any object of your own as iterable at this point. But for the most part, you're going to be using, arrays or objects, and objects are not directly iterable, but they do have this helper function. So you'll see if I try this, it's not going to like it. I need to fix these. I'm surprised that we have this database here. I want to walk through each entry. This does not work because an object is not by itself iterable, but I can say entries. Oh, sorry, that's not even right. It's object.entries. Okay, so it's actually on the main object thing. Let me just copy paste that in there. Sorry about the mistakes. I did all this Friday. I guess some mistakes got in. But yeah, exactly. So as you see, I'm able to walk through what object.entries returns, and what it returns essentially is a list, because lists are iterable, and the lists contain these lists which have, something in the first value and something, the key in the first value and the value in the second value. And the reason they do this is what we would call a tuple in JavaScript. So JavaScript doesn't have tuples for real in the way that Python does. So instead, we just will use arrays, and the array will only have length 2, and we'll just know, okay, the first one is the first thing, the second thing is the second thing. But yeah, object.entries is useful for that reason, and we're going to see it come back in a minute when we talk about destructuring. So what is destructuring? Or first, does anyone have any questions about for of loops? Fair enough. You've probably seen them a fair amount at this point. It's probably even considered the standard loop at this point. So here's this new concept called destructuring. You probably haven't seen this yet. Destructuring is one of my favorite features in any language, just because it makes it so that it's just a lot less cumbersome to essentially pull things out of a complex object or pack things into a complex object. So normally I would have a situation like this where I could have an array, and if I wanted to pull things off the array and give them their own unique variables, I would have to do something like this. Or alternatively, I would have to do something like this for an object, which is not terrible, but it is a bit, verbose for what it is. With destructuring, you can just do this. Well, I gotta delete this in order to do it, but so basically, instead of saying, okay, this equals a given list and then picking them off, I'm able to use the list syntax to say, call this one this, call this one this, call this one this. Same with objects, and this especially you'll see all the time, because very often you do want to grab a unique piece off of an object. That object could have so much in it, but you just want these 1 or 2 pieces, and you want to name them exactly what they're named in the object, and this is how you do that. I believe there are, like, if I wanted to name this hello instead of A, I could do that. And now if I were to write hello, no, I guess it's the other way around, maybe. Well, there is definitely a way to do this where you name something else like that. Yeah, exactly. But for the most part, you're just going to want to call it exactly what it is already called in that object. So that's destructuring, and it's worth seeing how these things like combine. Where, given that above example of my object.entries databases, so. Sorry, that's not in there right now. I'm going to go update that. But basically, object.entries return me a list of 2 returns me a list of lists with each one of those internal lists being a length 2, and they represent the key value pair. And this is just an easy way to get that key value exactly as it is. So you'll see a pattern like this a fair amount. Just going to add that in, but any questions about that, about destructuring or combining destructuring with other things? Okay. Yeah, I mean, I love destructuring, and basically with all the stuff we're discussing now, it's worth noting that like you don't have to do any of this stuff. And it doesn't make you a better programmer. It's just a matter of like, if you're doing something over and over and over again, it's nice when it can be concise and still be readable. And that's most of what this stuff buys you. Cool, the spread operator, that's another good one. So in my tradition of showing you how you could do things versus, you know, how you can do things now, originally you do things like this. You have an array and you have an object. If you want to copy the array, you use this slice function starting at the beginning of the array. I think that first argument is even unnecessary. It just assumes that. So array.slice is going to start at the first element and just give you a brand new copy of the array. Object has something kind of similar. It has this object.assign. You're basically using empty array to say a new, empty object to say a new object. And then you're assigning all the variables, or sorry, all the fields in this object, or the keys in this object, to be the key value pairs of this new object. And that works. So as you see, you have the array and the array copy, and we're modifying the array and the object copy, and they are modified without harming the original. So that is well and good, and you've always been able to do this, but it's, you know, who wants to remember array.slice or object.assign, even more cumbersome. So the modern way is what we call spread. Again, React uses these very heavily. So spread just uses the syntax again of an array and says spread what's in that array into this other array, or spread what's in that object into this new object. So that's all there is to that. And worth noting, there's a little bit more you can do where you might say like, well, what if I don't want to copy the whole object, or what if I want to modify it? Well, you do something like this. So you can start with a original object, and you can create a copy in which you spread the original, but because what comes to the right will supersede what comes to the left, you can just update something afterwards. And there's lots of other little things where, like, if I have an array that looks like, you know, const array equals 1, 2, 3, 4, 5, I can write something like const, I'm going to do destructuring, make it equal the array. And I could say something like, okay, X, and I just want to see what these equal. So X is going to be the first element, right? And I can continue that. I could say Y, Z, and you'll notice it's throwing out the variables it doesn't look at. But what if I wanted to say, okay, I want to get the first variable, and then I want to get all the rest of the variables? That's another case where you can use spread, where I could say something like Y, and now X equals the first variable, Y equals everything else in the array. And again, if I did like Y comma Z, that would work too. I'm pretty sure it doesn't work if I try and do something like this. If I try and do, we'll see if this works. It does not work. It gets confused. So there's a limit to how well these destructuring things can be combined with other things, but it's just shorthand that makes your life a little easier when you're destructuring something. Cool. So that actually brings us to the end of everything I wanted to discuss. And we do have another 20 minutes. I believe, let me check the schedule to make sure. We do have another 20 minutes. So yeah, we're going to give you assignments today that are just, you know, doing more JS. And you can use some of these, some of the stuff you learned, but you could also get away with using none of it, almost certainly, because like I said, variables, conditionals, and loops really are your core tools. and everything boils down to those. So as long as you have those, you can do anything the language can do. But yeah, with these last, I guess, 18 minutes now, is there anything in particular that maybe you've seen that you want to discuss, or something that we've discussed today that you want to go into more depth about?
Yeah, I just had a quick question about sets from earlier.
Mhm.
I was trying to look it up and I couldn't get something I'd understand about how searching through a set is done in constant time. Like, is it made as a hash table, or is it like, I don't understand.
Yeah, so that's a pretty advanced question. Just to explain what he's saying is, okay, so I have this set called set, and I don't even know if there's a nice way to initialize a set, if I can give it like the values 1, 2, 3 or something given. Hopefully that works. That's a set with 1, 2, 3 in it. And the question is, let's say this was a set with like 1 billion things in it, and I wanted to look up a specific thing. How do I do that? Or what basically in computer science, data structures matter because they give you certain guarantees. So for example, an array gives you constant time access to a specific variable, or sorry, a specific location. So you could say I'm interested in, array element 44, and it just jumps right to that. And arrays have to be designed to give you that guarantee. Similarly, with objects, you have this guarantee that if you say, I'm looking for object.x, wherever x exists in this, possibly gigantic data structure, you're getting constant time access, which doesn't mean really constant. It just means that it doesn't have to look at every object, or doesn't even have to look at half the objects. It's able to guarantee that it only has to look at a few, and that number is limited no matter how big the data structure gets. And we'll talk about that more when we get to data structures as an idea. But your question, just to ask again, is basically, how does it make a guarantee? Like if I say something like set dot, what does it get? Set dot has, yeah. If I say set dot has 2, that's going to return true or false or something. And your question is, how does it know so quickly or something?
Yeah, I guess I'm just a little confused about, because you know how with hash tables it's a key value pair, but with sets it's just individuals. Like, does it have as the key the index of like the location, like a pointer to the location of that value, or?
Yeah. So, I mean, it's definitely a relatively advanced question. And even the fact that we're mentioning hashes. So for those that are unfamiliar, a hash is this idea of essentially how an object is able to take a key, like, in that database, like basically there's no good reason an object like database should be able to say, okay, I'm interested in number 57782, and this is not in order, just give me that real quickly. The way it's able to do that is this idea called a hash, in which you're essentially converting this input value 57782 into another value, so that you only have to look at a handful of things. Relatively advanced concept that ultimately, like, we're never going to get to the point of implementing our own, but it is why you get some guarantees on some things versus others. So when this set is holding unique elements, and how is it looking them up fast? Let me think about that. I mean, if we're saying set has 2, yeah, I mean, this is an interesting point in that if I were to look up set on MDN, and this is sort of the difference between like when we're on MDN, we're basically looking up the specification, how it should work. And when we actually, type it in Java, or in like the Chrome browser, that's using Chrome's V8 engine, which is an implementation. So basically the documentation, whatever I just called it, like basically what this documentation tells you is how it should work and what guarantees it should have, but it's not telling you how to accomplish that. Whereas when Chrome makes their JavaScript engine, they have to make sure that it does work as expected, or that it does have those guarantees. And the way they accomplish that could be, the way they accomplish that might be The way they accomplish that might not be obvious. And part of the reason is because when Chrome is writing their engine to accomplish this stuff, they're not writing it in JavaScript, they're writing it in C, they're writing it in some other language that gives them low-level hardware access. And so they can do tricky things like hashes to make these guarantees, but all we really know is that we have that guarantee. So yeah, I don't know that I can answer that question especially well of how it's accomplishing that guarantee. But you can rest assured that if anyone is implementing something like this and has a guarantee like that, it's, at the very least, it's not a good implementation, and probably not the kind of implementation a company like Microsoft or Apple or whoever, you know, maintains Node. Those guys make sure that they meet the guarantees of the specification. Is that a good enough answer? Or?
Yeah, thank you.
Okay, fair enough. Yeah, but I mean, it's a very good question. It's just the actual answer is complex and could take 2 hours on its own, because we'd have to get into like actually implementing a hash algorithm. Cool. Anything else? We still have some time. Any features of JavaScript you've seen? Anything in particular that is weird that you maybe want to talk about? Maybe you just want to see weird JavaScript things. There are lots of those.
If you could, we
yes.
were kind of starting to chat earlier about maybe a high level overview of the comparison between TypeScript and JavaScript.
Fair enough. When did that conversation start? Like who?
In the chat, I asked right as we were going on break a while back, I just asked when a good time would be to maybe talk pros, cons, and how
Okay.
they relate.
Cool. Yeah. Well, in order to do that, I'm going to open a little personal project, because I will tell you that I much prefer TypeScript at this point, and we can talk a little about what TypeScript is. So let's open this silly little diet calculator I made. Okay. So yeah, so the first point is that what is the difference between JavaScript and TypeScript? So JavaScript is the real language. JavaScript is what your browser runs. It's what Node runs. And it doesn't have it has this idea of dynamic types, but they're not so useful. Whereas other languages have what are called static types, which means that before your program can even run, you're going to have this step by which your compiler or whatever runs your program is first going to look through all your code and check basic type information. And if it doesn't make sense, it won't let you ever run the code. And that's a really good use for types, because types are just ways of guaranteeing that something is what you said it would be. So let's look at this food item thing. This is a good example. So the basics of TypeScript are that it's going to eventually turn into JavaScript, but it gives you things like this, where you could say, okay, well, I have this function. This function takes an input, not any input. That input must be a food item, and it returns an input, and that input must be, it returns an output, and that output must be a food item. I'm actually just going to open a separate file to work in this. Actually, we'll just do that here. Within this playground, I'm going to first turn off Quokka, because it's probably going to not like it. Off. Is there a way? Stop all. Okay, great. So first, we have this thing called playground. I'm going to rename playground to playground.ts so that it understands it. And we'll open that. So TS just being an extension that means TypeScript as opposed to JavaScript. Normally you have this command called TSC, which I probably don't even have installed. And TSC would take a TypeScript document and output a JavaScript document. But there's this helpful thing called TS Node, which I do have on my computer already. And that's much like Node, just going to run a TypeScript file. There's nothing in here right now. But if I were to write console.log hello, just like it was JavaScript, it would work. And the thing to note first is that all valid JavaScript is valid TypeScript. TypeScript just gives you a few more things where you can say, okay, well, I'm going to make this variable call, or not variable, I'm going to make const phrase equals hello. And this looks just like JavaScript right now, where it's going to understand that phrase is a string. If I hover over it, it's actually, because it's constant, knows it's a specific string, even more careful. But in this case, it knows it's a string, and this all works. But as it is right now, I can just say later phrase equals 1, and that still works. Interesting, it's actually forcing it to be a string. But in general, you'd have to write something like this, where you say phrase is a string, it has to be a string, you can't change it later. Whereas if I said phrase was of type any, I could do that. And the big take home is that in JavaScript, everything really has type any. So it doesn't matter what you do. Whereas in TypeScript, you can be careful and say things don't just have any type. And if it has any type, I'm going to be explicit about it. Otherwise, give it as narrow a type as you can. So that's the main thing. If I created a function, I'm going to create a function add nums. These are silly functions, but basically, normally I could say something like this: add nums x plus y, and that works. Where I could say add nums 1 and 2, but I can also just say add nums a and b, and it has no problem with that. But I could say I do have a problem with that. Add nums takes numbers, so that first thing, it has to be a number. This colon, you read it as type of. And then because a function returns something, we say that the whole function has a type, which is going to be number. And so basically I'm saying, if I take two numbers, I return a number. And so this is broken. Functions declare type is neither void nor any. Oh, because I'm not returning it. Exactly. So even with just this, it's going to complain because it's going to say, hey, you said that you take two numbers and you return a number. No, you don't. You're returning void right now, which just means you're returning nothing. So the big benefit of TypeScript is that it catches these sort of errors for you. And the way I see it, like eventually we're going to get into software testing with when we do like web development, and we'll talk about unit tests and integration tests. But something like TypeScript represents a class of tests that is so, or a class of bug that is so common and so understandable that the tests for it are just baked into the language. So just by adding these small things, we're able to make it so that this function tests itself. This function doesn't work unless the input matches the right shape and the output matches the right shape. And that's very useful. And then the only additional thing is that you can make your own types. So I could say type number or string, and type number or string can, be a number. You could say or string, so that later I could say, let x equal 1, and that works. And then I can say let x equal, reassign it to hello. And does that not work? Oh, sorry, because I didn't say x is explicitly, x can be a number or a string. But then if I try and say x is true, now it's going to complain because that's not part of my definition. So those ideas all together, just it ends up, sometimes it'll look a little more cumbersome, or it'll look a little uglier. You end up having to write more, but you're being very explicit about what you want and what should and shouldn't work. Yeah, and we don't teach you TypeScript in this course, but we do eventually in like when the course ends, there's like I forget what it's called, like level up or something like that. Like we have some program at the end that will introduce you to some ideas that are relevant to the job market and things like TypeScript. I would really love to eventually fold TypeScript into the class, because even though it's an addition on top of JavaScript, the latest polls say something like 85% of new JavaScript projects are written in TypeScript. And there's good reason for that because there's no downside. As in, if you took all this out, if you took everything out that looks like TypeScript, TypeScript is perfectly valid JavaScript. And you might say, actually, no, it's not, because it's complaining here that, this should be a number, but all those features are configurable. So if I had a TypeScript config file in here, I could say, by default, it has this thing that says, don't allow implicit any's. But if I turn that off, then basically by default, everything will be an any, and then it doesn't care. But yeah, that's the big benefit, or one of the big benefits of TypeScript, is that it's not actually expensive to adopt, in the sense that you can implement it and configure it in such a way that it just doesn't warn you about anything. It just accepts any old JavaScript. But when you do let it do its purpose, it's going to help you a lot. And I also know that even Python is also an example of a dynamically typed language, but even Python at this point has some support for like typing. And it makes sense. It's just Rails basically. So like if you were to build a staircase, it's not a bad idea to include Rails, because they'll prevent people from falling off, and people do stumble sometimes. And a perfect programmer has no need for a type system, but that's usually not the case, that you're perfect or that you are keeping track of everything going on. And as a software project gets bigger, you're going to make these mistakes. And so Rails help. And basically, if Rails help with a regular staircase, imagine how much they help if you're building an incredibly complex staircase, which sometimes, sometimes the steps aren't exactly the same length. Sometimes it's a spiral staircase. And like, the more complexity you add to your system and the higher you build it, the more it makes sense to have Rails. Otherwise, you're just asking for a terrible accident. Okay, so we are at time. Hopefully that little discussion of TypeScript was useful. But yeah, I think we are at time. We're good. I'm gonna look at the schedule right now. I believe you and I both have off for lunch right now. That's right. And I guess this whole section on your calendars probably says that at some point, probably like what, 1 p.m. How long do we have for lunch?
Till 1:30.
Until 1:30. Okay, great. So starting at 1:30 until 4 p.m. I guess you guys are going to be working on the assignments at the bottom of that. At the bottom of that document, which I made a few typo fixes to, so I'll push those changes. And yeah, anything else, Zainab, before they break for lunch?
No, I think that's it. And it's 4 p.m. Mountain Time, but 5 p.m. Central, just in case people.
Sorry, I keep giving you guys Mountain Time.
No.
Just to CST, but thank you for the call out.
Of course. But yeah, I think that's all.
Okay, cool. So I'm going to stop recording and stop sharing my screen.
Sounds good.